What's going on, arcade nerds? Well, this is going to be part 2 of the Vector Berserk build. As you can see, the garage has really gotten muddied up. It's packed full of crap. My goal is to get this garage completely empty, because at some point I want to get my Datsun in the garage and work on it over the winter. And yeah, just the junk keeps growing and growing and growing. Let me tell you about what just happened. I just made a complete part 2 Berserk video where I worked on the electronics side of the Vector Berserk cabinet, and every bit of that data is corrupted on the SD card, and I can't get it back. I did, which makes me sick. It really pissed me off, because that was a really great video. So what I'm going to do is, oh, and I use some like corruption restore software, and it was like a free software, but if you wanted it to actually do its job, you had to pay $90 to get the for the software to work. In other words, I ran some software and it says, hey, we found all your files, but we want $90 to do it. And I just couldn't pull the trigger for $90. So unfortunately, I'm going to give you a subpar video. Instead of like, hey, let's go along with me and do this, I'm going to have to show you, hey, this is what I did kind of video. Does that make sense? So yeah, let me explain some of the junk in my garage. Like I said, I'd like to have this garage cleared out so I can get my car in here for the winter. But a friend of mine contacted me and he says, hey, I want a Quantum. Can you build me a Quantum? And I said, yeah, sure, yeah, you can build a Quantum. And so I contacted another buddy of mine, and he cut out this Quantum cabinet, which I may do a video of putting this Quantum cabinet together. And putting the artwork on, putting the harness in, putting the board in, getting the monitor working and all that. So I may do a video about that. If you guys are interested, I don't know, leave a comment. And he also wanted me to put together these 2 brand new title cabinets. Now, he wants to put Zabo's artwork, or wants me to put Zabo's artwork on one of them. So it's an Arkanoid in a Taito cabinet. And he wants a Jungle King, which I think he's going to do on his own. But anyways, the deal is, normally I try not to do stuff for other people, when it comes to arcade stuff, because I don't have much time on my own. If it was my own, I'd be putting it off. Like, I've been putting off that food fight for years, But he offered me like pallets and pallets of like Vector monitors and stuff, and so it was actually a pretty sweet deal for me to do that. So yeah, anyways, unfortunately my SD card is corrupted, so I guess I'm going to go to the basement and I'll just kind of do a show and tell and explain what I did and why I did what. Okay, now if you didn't already guess, the Vector Berserk cabinet is going to be Vectrex based. And the original video I started off and I said, hey, I'm going to fix one of these Vectrex boards, because I'm not going to destroy a perfectly good Vectrex to put in this cabinet. So anyways, what I did was I found out that these caps right here were bad on the one Vectrex board, which previously didn't work at all, which is funny. And it just ended up needing caps. So I put caps on that board, and I mounted it to this piece of wood. You see this? And I have the color board connected, and the way this works is the color board is getting 5 volts ground and Z out from the Vectrex board, okay? And X and Y, I should say, also. And what that's doing is this board is converting intensity data into color data. So it's converting how bright the beam is and dividing it into sections, and for every level of brightness it is making it a color. So when I originally did the video, I said, hey, I wasn't really happy with the original boot screen. For example, when the Vectrex boots up, it just says Vectrex, GCE, entertaining new ideas. And I thought, you know what, let's change that around and let's make it something cool that will go along with the BERZERK machine. So let me show you on the computer what I did. Okay, right now I'm using a hexadecimal editor. This is a free program you can get online called HXD. And what it allows you to do is it allows you to view the ROM contents of a ROM, of course, the contents of a ROM. And it'll let you see the hex values and the ASCII characters to the right of it. So if I were to show you this, okay, this is the original BIOS, and it's really simple. Check it out. I can actually read it. GCE 1982 Vectrex, entertaining new ideas. Now, when the Vectrex first boots up, it shows Vectrex, and then there's the other Vectrex. Now, if you notice, when the Vectrex boots up, it flashes. It kind of flashes like one Vectrex image over the other Vectrex. So it kind of gives the illusion of a flash of the text. And so I wanted to change that. I wanted to change it to something else, you know. And so what I did was I edited it. Now I'm going to switch over to the edited version. Now you see how it now says BERZERK 2020. And so and also on the bottom it says destroy all humanoids. I put that into the code. It's really basic. There's nothing major about it. Although at this recording right now, a friend of mine, I told a friend of mine that I messed with this, and I said, boy, wouldn't it be cool if I could make it cycle through colors. And so he actually wrote a special BIOS that actually cycles through different intensities. So the boot screen should flash in multiple colors rather than that purpley pink that it normally does with the color mod. So I may actually switch to that later on, but just for the purpose of showing you what's going on, I am going to show you what happened after changing this little bit of code. So, the code that we're using was written by Malbin Vide, and what he did was he got a BERZERK, the BERZERK ROMs for Vectrex, and he colorized them and modified them for use with the color board. And so I need to make my own Vectrex gaming cartridge. So what I did was I already made up a bunch of these color calibration cartridges. And this was for use when calibrating your color board. And here are some defects. Now when I say defects, these are fully working, but the silk screen is off. You can see the silk screen's all chopped up and so on. And so I just went ahead and assembled one of my color boards and just added the BERZERK code to this chip, and rather than the color code. Okay, so this is my new ROM, and that ROM plugs right into the Vectrex, just like that. Okay, so let me explain how this works. Now, I do not need the Vectrex deflection board because I'm not going to power a Vectrex monitor, but rather I'm going to power an arcade vector monitor, a color arcade vector monitor, Wells Gardner 6100 in this situation. So. So why do I have this giant thing just for the power supply? Well, I'll tell you why. I'm going to go ahead and use this deflection circuit, and because this deflection circuit is going to power the vector monitor which is built into the Marquee. And so what I'm going to do is, let me grab this. This is just a little test circuit board that I made, and it just so happens to work. What it does is it boots up on an SD card. Okay, the SD card basically plays an MP3. The MP3 audio file goes through these two op amps to an acceptable level to be read by the Vectrex deflection board. Now the Vectrex deflection board will show that on my homemade vector monitor, which will be built into the Marquee. Oh, I got the sneeze. I got a cold now. I'm gonna sneeze. Okay, I lost my train of thought here. Anyways, I'm using this to power the Marquee, the vector monitor inside the Marquee. The problem is, this generates its own high voltage. I certainly don't want a high voltage anode just sitting there, anode cup, just shooting high voltage everywhere, right? We can't have that. So let me show you in the schematics what I did. Okay, so here we have the Vectrex high voltage schematic. Now, as you can see, it runs a 555, now pin 3, it couples through this capacitor, then goes through this transformer. But really, the major thing that drives this is this transistor. When the voltage comes at this base of this transistor, it connects the one power line to the other power line through the primary coil of the flyback. So I figured, well, we have a couple different options. I could cut pin 3, which would disable the frequency going to here, but it's a slight possibility that you could get random stray voltages that will trigger this randomly, and I don't want that. Or I could cut one of these inductors. But what I ended up doing was I ended up cutting all 3 pins, base, collector, and emitter, off of this transistor, which completely disables the primary coil, and so any of these voltages coming off the flyback is now dead, now disabled. So let me show you on the board where that is. Okay, we are now looking at the power supply slash high voltage slash deflection board. See this transistor? I cut and lifted all 3 of these pins. Now, this isn't a big deal. I'm not ruining anything. In fact, I have an entire bag of these transistors, and if or whenever I decide to convert this back to an original Vectrex board, I can always just put a new transistor there and we're good to go. Okay, remember how I mentioned in the last video that there's going to be a vector monitor inside the Marquee, and that vector monitor will be like a track screen or something like that? This is what I'm planning on doing. Right now we're looking at a program called Blender. Now, a friend of mine made this BERZERK logo, Marquee image, in Blender for me. Now, with Blender, I can connect Blender to another program called Aussie Studio. And with Aussie Studio, what it is it's basically it's sort of a vector monitor for your computer. What I can do is I can display that same image from Blender right here, okay? And this is emulating how a vector monitor would work. See right there, I can mess with all kinds of things. For example, I can mess with the frequency. Now this is going to emulate on how a vector monitor is going to handle this. I can go way out of range. Now I personally kind of liked it really slow, if I can do it. I kind of like that. It's like extra vector flicker. That frequency is actually at 10 hertz. But 10 kilohertz, I believe. But anyways, I can also change stuff. I can also change stuff like, oh, let's say rotate. I can make it rotate if I wanted to. Or, see here. I can change how it's displayed, like. This one's kind of interesting. Oh, this one's kind of interesting too. But yeah, you get the idea. There's all different kinds of options I can play with, right? And so what this does is, I can make this image, which is fed to it by Blender, and then I can record this image, like this, and I can save it as a WAV file. Now, that WAV file will then go onto an SD card, and that SD card goes into this programmable MP3 player. And what this MP3 player does is you can make this work with Arduino and so on, but the way this works is I have it set up so the SD card goes in, a WAV file is on the SD card, and temporarily right now I press this wire, I ground this wire, and it starts to play an audio file to the Vectrex. Now, as you can see, I have the Vectrex connected to the MP3 player. Okay, so let me show you what it looks like on screen if I can. About to sneeze. Now this is going to be a dim image. Hopefully you can see that. Can you see that? Let's see if I can shut this light off. Hey Kelly, can you shut the light off? I got the big microphone stand here. Or, hold on. Never mind. I didn't know you had to walk all the way around. I thought you were just going to go here. Okay, so now we're in the dark a little bit. You can kind of see where it says BERZERK. Why is this so dim? Well, the Vectrex has a spot killer circuit inside, and this is not running fast enough to trigger the spot killer. And so that's one reason. And just as a temporary thing, I can ground out the cathode and show you full intensity, which of course isn't a proper representation of what it's actually going to look like. But yeah. So what was I going to say? Oh yes, you see how the B here is like doubled over and the K is doubled over? There's some work to be done with this image, and I'll have to figure it out at some point. I'm no wizard at Blender, but for some reason everything's being drawn twice. If I can get it to be drawn just once, then it wouldn't have the double image. Well, we do have a problem still, and the problem is I ground this pin out right here, and it will play the file. But when the file's done, this does nothing. So in other words, I need to be able to press this button every once in a while to keep the video playing. And and sure, this can be done in many other ways, but using this simple hardware, this is my only option to keep it playing. Luckily, when this button is pressed, it restarts the audio file seamlessly. There's not even a gap. It instantly starts it, which is pretty cool. So you would never be able to tell when this is being pressed. So I suppose I could build a 555 timer circuit and have it go every 30 seconds or something like that. But you know what? It's just so much easier to just stick a microcontroller on there. So that's what I'm going to do. I'm basically going to stick a microcontroller. We're going to run like a Blinky program, and it's going to run a signal to this pin every, I don't know, let's make it, how about this? I'll probably end up making it hit reset or play again every minute, but the actual audio file will be, let's say, 2 minutes long. That way it'll never actually reach the end of the file. It'll constantly restart and never give me that dot in the middle of the screen, because remember, this whole setup is going to run without a Z signal. So in other words, Z, or the beam, will be turned on at all times. So we're drawing a picture with the beam all the way on, right? And if this were to stop playing, we'll have a beam stuck in the middle of the screen, and we'll end up destroying the monitor. So we can't have that. So yeah, so I guess that's what I'm going to do. Okay, so here's my code. Pin 15. See, this is actually a standard code that, it's like the first thing you ever learn if you ever want to mess around with Arduino. And the program's often called Blinky. But what we're going to do is, rather than an LED, we're going to hit the ground pin on that. We're going to ground out that pin on the MP3 player. Okay, so as you can see here, it will be high for 10 seconds, and it will be low for 1/4 of a second. And so that way, every 10 seconds is going to basically press a button. So all right, let's try it out and see if it works. Okay, so I hooked up the microcontroller and I wired that one pin to this button, to this pin over here. And all I did was connect 5 volt and ground to this 5-volt and ground. Now, temporarily, just as a test rig, I'm using my 5 volts off a USB cord. Okay, so also I decided to make it every 5 seconds for it to refresh, and the reason why is because, let's say you first plug the machine in, now you gotta wait 30 seconds or whatever for that beam to sit there and burn the screen. So I figure 5 seconds would be enough for just for the tube to just begin to light up, and then it will do this thing here. Okay, so I'm going to plug this in. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. You see how that light turned on? Okay, so in every 5 seconds or so, it'll restart the file. Whoops, it'll restart the file. Good enough. Good enough for government work. Okay, so I guess let's mount this to that board, and I need to go find my speech module, and I will make, by the way, this game supports speech, but it needs a special speech module. So I'm going to connect a speech module to this board, and I'll have to figure out where to mount all this crap, and I'll catch up with you in a minute. Okay, so we have now added this board, and now I'm going to wire in this guy. This is the speech module. This is what's called an Atari Vox. This is just so happens to be the Atari Vox version that's meant for the Vectrex. And the reason why I'm using this is because excuse me. The reason I'm using this is because this software supports the Atari Vox. So I want this sound from the Atari Vox, or this speech, to be mixed in with the amplifier on this. And I cannot just simply connect it to the board, because it needs to be coupled through this capacitor. So what's going to happen is, this Atari Vox, I added a wire. Okay, that wire will go through this capacitor and this 47 kilo ohm resistor, and be soldered directly onto this pin right here, which is normally where the volume pot is. And that's it. I should have it working. So let's hook it up and see how it goes. Okay, so this is the control panel. This is actually a new old stock control panel that a friend gave me. He bought reproduction, not new old stock, I should say reproduction. He bought a bunch of reproduction panels that were defective. And so these have a few little scratches here and there, and I'm okay with that. That's kind of cool. But what my wife has done is she wired in this. And no, we didn't write all this crap on the back of the wood. But she wired in this breakout board that allows you to connect a Vectrex to any controls you want. And so that's what we're going to do with this. We now have this board mounted, and I did connect the 5 volt and the ground to this. And here is where that resistor and capacitor are. I put it inside some shrink wrap tube, some shrink tube. And that's it. I guess at this point, all that's left is to connect this to the vector monitor inside the BERZERK cabinet. And also I added these terminals here in this little barrier strip. This will allow ease of connecting to the speaker built inside. I do have one more thing I need to do. I need to make a connector and a cable to connect from here to the output of this op amp. This is op amp, of course, is what's going to display the picture, the vector for the vector monitor in the Marquee. And I will use this connector here, which is the original yoke connector. And that yoke connector will go all the way up to the side of the cabinet, all the way up to the back of the yoke on the monitor inside the Marquee. So, do you want to see this work in color on work on the real machine? You'll have to watch the next video. But what I can do is I can plug this in and show you what it sounds like, and show you all the goofy LEDs that are on this thing. So, here we go.
Atari Vox. Vox activated.